Where should we start, Professor, bringing in all those other ratios that we need?
Yeah, so there's a theory here. So you get more and more and more sophisticated. So this is when you start thinking about what is a good company. So, good company has good revenue growth. They also have good asset turnover. But the other thing I like is not only do they have good asset turnover, but their asset turnover is improving. So I might look at their asset turnover, but I might also look at this year's asset turnover and compare it to 2 years ago. They have good margins, good gross margins, good net margins, but I might also look for a firm whose net margins are improving. They have good return on capital, good EVA spreads. And I thought we talked about maybe seeing what Bloomberg offers on working capital, see if they have a ratio that everybody in working capital. Essentially, you're just asking, how do you define a good company? You want to bring in all the data that defines a good company, and you're going to rerun the model. What did we get last time? Did you actually run the R squared and all that?
No, we did not.
All right, so go off to the
What's
right.
that? We did?
I did all this stuff. Yeah, you did. Did we run solver too? Yeah. Okay, so you got that far. All right, so let me show you how to add one. All right, so go back over to the left. So all the way over. Let me just say a quick way. So let's see what's a big one. Do you have asset turnover in there?
Yeah.
You have asset turnover. Okay. Well, next to that one, insert a column. And up at the top, the Bloomberg search. Find fields. Make sure you're in that one cell. So make sure you're on row 1 or row 2. I just typed the word working capital and see what they have to offer. What comes up?
Working capital, net working capital, capital investment, modified working capital to sales.
Do they have working capital 2? And you can put the word 2 after that and see if they do a ratio for you. No, not to TL. Working capital to sales. That might work. Let's try that. So what do you want? A higher number or lower number? Let's see how correct your accounting process is. You want firms that have a lot of working capital, a lot of inventory, a lot of receivables. You want firms that have limited working capital.
Limited.
As small as possible, right? So if you want a smaller number, so bring that in, so close that. You can copy the formula over from column H. And you know, following numbers. You can copy that down. So, copy this, so.
Everybody know what I did there?
Walking through what you did, it does that sometimes. You just have to wait it out. Sometimes you can get the TV sometimes any connection is not bad. There's another one called limit any connection just means some reason they're not talking to each other. You can switch this machine if you like. I can grab this. Yeah, any connection rules. It's kind of banking machine. Data, or is it also like,
Are we gonna be ranking everything, Professor?
yeah, so wherever you insert a column I, you want to go over to the ranking, you insert the column in the exact same spot.
To the right of it?
No, over to where you want, go over to the ranking. Find where you put that, you put add a column right at the same place. That makes sense.
Okay.
So between.
So we just added a column J, I'm sorry, column I for working capital. And now we're gonna add one to after column P.
You want the exact same spot, so you just copy everything over. So now you can just copy the column P and just put it over there on the column. Put it in the file. No, copy from the previous stuff, not from that from P. That's the reason I said you want to reference them, not just type them in. Click below that. Copy that.
Nice.
You can just click on the P. Column.
Do we need to run our solver again?
Well, put 0% in the first row. But if you do it like this, as long as what you add is in between what you did before, it's automatically updated in the solver. You don't have to change anything to solve.
Nice.
So it's a real easy, fast way to add more factors. Once you get the skeleton of the model set up, or you can add 20 more factors in it.
Good to know.
Now here you can do column 1 or column 0. So higher is bad, is you want column 1 on this one.
So 0 makes it descending order, 1 makes it ascending order.
So what we want to do is 0, 1. Right, you copy that down. No, when you just change the 62. What you as far as I'm going to say, a lot of questions.
Forgot that we already went.
All right, so what do y'all think we should look at first? Solver already automatically updated.
Well, you have to run it, but you don't have to change it.
All right,
Just let solver and go.
go to data.
And you might not have solver. Nice thing is you don't set it up because we set the file and have all this fun stuff. So it didn't allocate into it, so it's not gonna help the model, but we probably, I mean, that's, my point is to show you how easy it is to add one. You can do that over and over and over again. Yeah, he set it up, but you can set it up yourself. Maximize. All right, so now the question is how can you get this much higher? So think category by category. So you've got something in working capital now. You can try an inventory turn if you want to, fine, but I think you can get a lot of NAs if you do that, which is really frustrating. I'm trying to think of the past what has worked well. You got the default probably in there, right?
Mm-hmm, 5 year.
Did you do the EPA as well?
I don't believe so, no.
It doesn't always work, but it can work. So, so to the left of the 5-year default column, not on the ranking, but on the data on the left. We start first with the data. First and go over. So you insert the column, know where you're inserting it. Go get EBA spread. Get that EBA find EBA spread.
A little bit. Whack economic value added spread.
Well, it would be whack EBA spread. Yeah.
Oh, yeah. Makes sense.
EBA spread should be bring it up. Is that it?
Yes.
Whack EBA spread. Yeah.
Click on that and then go to apply. Then close. Now that we have the name there, we can drag over the formula from the column before. A lot of negatives here.
Well, zero's kind of expected, so hopefully don't have anything negative. So now do the same thing on the ranking. I don't know if EVAs can help you much, but it might. I'll have to cheat and look at the last two model.
Okay, so you put it in here. So this. Right, so we got one change you gotta make on this one. One, six. What we're doing is really well, it's
Not necessarily how accurate the data is, but how well
they give it enough to explain what.
So which company? Like how well it's
Yeah, like how much, how much, so we don't know. How well. Basically, how well they move together. But they move well together, and we know.
So we actually see with the
So they do that. Then we don't have to.
like a lot of things.
And how to do it.
So the key is, between the 36 and 75.
Mine doesn't go up to 70.
Well, it can be. So like here. The market has increased. We went from high. So we're trying to find farming, we went. So we can. A high ranking here. This would be the worst. Yeah. So it's a 6 month. Right, now, to get a chorus, there's no opportunities. Every song is perfectly priced according to our model. The chorus is 0, and says, well, we're right, it's not buying stuff. So it makes us nervous, or we can always stop the market. Chorus and 80.
Waylon, how you doing back there? Good. What is everybody's return for their solver right now? Is it 0.67? You guys have 0.67 as your solver return?
Yeah.
Nice.
No, that one's he put it in row 1. What's in W1 versus W2? All right, so I was going to look at the last model and see if I can find, given that number on the machine point, talk me through that.
I'll definitely borrow this one real quick if you want.
So we've had really good success with this customer in the past to get up into the 80s at least. So I know it's possible. But one thing you can do is do that XY graph and see if you have any really major outliers. Sometimes picking out 2 or 3 outliers can really help the model. So you might start with that. So you got your ranking, you got the market's ranking. If you have like the market ranks someone on the Y, you got them on the 127, that's probably messing up.
So graph the rankings.
Yeah, just select those last two columns. And then do an XY graph.
So click on X. You can click on X2 and then Control Shift down and to the right one.
So you have a few outliers that is especially on the left. And those 3 up in the top left. No telling how much they're hurting. It doesn't look like they're hurting it much for dramatically, but it's definitely you probably get another 3 or 4 points if you got rid of those 3. The struggle is finding them.
Clicking on it won't highlight it for me.
No. You find them, see what the number is, and go in and see. Another way to do it is, you can try this, why don't we try this? Click out of that graph, just get rid of it. And up in the top, in that column right there to the right, go right below the 64. And there be plus the first column minus the second column. And you see how the difference is. Copy that down. Now what you can do is highlight the entire thing and sort it by that last column. And that'll show you what the biggest differences are. Does that make sense?
Yes.
It's like the entire, all the data.
All this data? Or just
The whole model, even the names, and the tickets, select everything. Select that entire thing and sort it all by that last column. And don't select rows 1 and 2. Select rows 3 on down. Select everything 3 on down. And then sort by the very last column.
Z.
There you go. That's it. All right, so we have the biggest differences at the top. So this is what you can do, Don, so you don't mess up your model. Rather than deleting those rows, just go over to X and Y. No, leave them in, don't leave the companies. But just go over to X and Y and highlight their ranks and just get rid of the companies that are, just hit delete. Don't make the whole row, just delete those two cells. And see what happens to those squares.
Already went up.
Yeah,
So, yeah.
you might delete the top 5 and the bottom 5, something like that, and see what that does.
All right.
So we had a few outliers more on,
So let's do the bottom 4 down here. So X and Y, 106 through 109. Brings us up to 77. And now let's do 4 more. So it'll be X and Y, 4 to 7.
eventually you gotta look at what they're deleting, just in case it's a massive important company.
And it brought us up to 85.
Yeah,
We deleted the tobacco company, Beyond Meat.
oh, yeah, maybe really, that's all. But you know Beyond Meat tells lies because they just got a big McDonald's, so you got a company whose history is horrible, but they got a big contract, so obviously, hopefully you ranked it really low and the market ranked it really high. That would be my assumption. I don't know where we are. You know, that would be my assumption.
Well, we can, let's see. It's in row 4. So if you hit undo and you leave row 4, then you'll be deleting X and Y 5 through 7. So we'll leave Beyond Meat there. And it still puts us at 82 for our solver number.
Do you have pivot dollar margin in yours? Do you have dollar margin?
Yes, we do.
That was the highest rank in the model.
EBITDA to revenue.
All right, one thing you really liked this last time, it makes it really messy for the model. It was called EVA expansion, where they looked at the EVA this year and subtracted it from several years ago. And higher would be better. You might be able to do all that in one formula, but I have to show you a new formula because when you start pulling in data for specific years, a formula gets much longer. Have you seen that formula before?
I think I think you showed me and you said if you want to change something, you change this little area of it.
Yeah, so well, I have to get you that formula because I can remember it, but I'll get you that formula and then for next week. That's something this model really liked. It didn't like EVA, but when you look at the change, and that's something that, CFO will actually say, it's not EVA, it's the change in EVA that market's figured out. So that would be one to add. Other than that, I think you've got everything. Oh, for some reason, stock volatility was a big word. That one's an easy one to add. You may want to try that one. So put it next, put it to the left in the default probability. Just do one by search.
What's the function?
Well,
What's the function?
yeah, just type 90-day vol.
Volatility 90-day.
Yeah, all of them 90 days. It's nothing more than the standard deviation of the stock price the last 100 days. Buy and close. Copy the formulas over. Yeah, easy it is once you get the framework, or you can add more factors. Yeah, it's those two things, EVAs, change in EVAs in 90 days, and they got to R squared up with something else, I can't tell, but it was much higher than yours.
And then again, to the left of 5-year default, add another column.
Actually, just click on the column, entire column, next to it. Control C,
Like that.
Control C, and go over to the next column and row one. Just all right, so we run solver and see if it does like it. You never know, you don't like it. Now, I don't know why you're getting you're getting a value on one of them, so you'll have to let one on, that may be beyond you. But why are you getting a value on one of them?
It's 22 century group.
All right, just since that's not in your model, you can just leave on that one. See if you have any other volatility. How can you get a volatility of 98? How can you get a NA on 98? The only way is if the stock has only existed 90 days. All right, try solver and let's see.
Still the same.
It didn't happen. Okay, so the market's changed their opinion on that as well. But you tried it, right? Well, you only have a few minutes, so next week what we can do is I can show you how to do that EVA comparison, and there you have to specifically tell them which year you want. And that formula, it's a much more complicated formula. We need to write that formula on the board because I can really remember it. You might be able to do it all in the same cell, be kind of complicated, but in the same cell, take 1 year minus the other year, so it's going to be a massive formula. You can't do it in one cell, then what I recommend is off on the right, bring in the 2 years, and then over on the left to do the difference. That way, it gets complicated if you're ranking and your other columns aren't exactly the same. You got 7 columns, if you're going to rank, you have 7 columns, 7 columns ranked. If you have one thing you're going to rank us, you need like 2 or 3 columns, and do that off to the right. You already calculations in one column and then do a ranking. I'll have to get you that formula.
It sounds
Well,
good.
you're up to what, 77 now?
83.
83. I mean, that sounds good, but what is 83 times 83? That's your R squared. So your R squared is only about 65%.
What's the last, year?
I think they were R squared and the correlation is about 90. I'll have to look, I'll see.
All right, good job, guys.
You're getting higher. And the goal isn't to find the stocks you're going to buy, the goal is to find your surplus. So we can try the EVA spread next week, and I'll show you how to create the buy, sell, hold. The way I do it is my philosophy is, we're looking for the biggest difference, right? We rank it high, but it's cheap. But the other thing I want is that we rank it high. So I want stocks that are like in the top 30%, but the difference is like 10. They're in the top 30%, but they're much cheaper than the market. So we put those two things together. If they match those two, we put it in the buy list. If they only match, maybe they're not in the top 30, but in the top 50, and the difference is only 5, we put it in our hold list. Everything else is in our sell list.
That's
So you're getting close. Only
Nice.
2 weeks in, I think a decent first one. The pressure from out there. Right, yeah. Sweating.
I'm trying to stay one step behind him so I can learn from him.
Yeah.
Very cool. All right.
Thank you.
Yes, good job.
Great.
Thanks for coming, Larissa and Waylon. Hopefully you learned a little bit.
Okay, I'll get started. So, for today's agenda, we're just gonna finish up the data types, which are the sets and tuples, and then get into control flow, some loops, and then some cumulative exercises. And I think that once we get into control flow, it's gonna get a little bit more interesting, because learning all the different types of, all the different data types is kind of like learning the alphabet of the language. Once we get into control flow, you can get creative and it's a little bit more fun. So sets are, they're denoted by the curly brackets, kind of like dictionaries, and they're unordered collection of unique items. So since they're unordered, we can't index them, and unique, so there's no duplicates. So you see over here, I created a variable with a set variable, bunch of repeat numbers in there, but it only gave me the unique ones. And then I also tried to index them over here. So the very first index, it gave me an error. And then tuples, they're denoted by parentheses. The key difference, they're really similar to lists, just the only difference is that they're immutable. So they don't support reassignment. So over here, the top is a list because it's denoted by the square brackets. And you can see I reassigned the very first index to the string 1. And I printed it out, and then you can see that it actually changed. But the bottom one is an example of a tuple. It's in parentheses. It's the same list. I try to do it again, but it'll give you an error. Now here's more interesting stuff. So, when we're creating a control flow, we might only want to execute something if a condition is met. So, for example, like if my alarm goes off, then the action get out of bed. So, control flow syntax makes use of white space, new lines, and colons. And then 3 of the common keywords used in control flow are if, elif, and else. And so here I have an example of the syntax. So the keyword has to come first, so if, and then we have some condition, and you can think of the colon, new line, and then the little bit of space is the then. So if some condition is met, then some action happens. And then the white space should be about the length of well, it is the length of the tab. And if it's not, it's like more or less, it's gonna, in the IDE, it's gonna change colors and it's gonna show you. So here, an example. So if the time is 6 a.m., print wake up. And then we have elif. So elif is a combination of if and else. So it's used if the first if statement that we have, if that condition isn't met, then check for the next condition. So example here. So if it's 6 a.m., print wake up, elif, the time is equal to 6:15, print hurry. And then, so why do we use elif versus multiple ifs, which we can do? Using multiple ifs, it's going to check for a condition if it's an if, no matter what. But using elif, it's only going to check for that condition if the if statement above that one wasn't met. So here, so for example, so the elif right here, it's only gonna check this if statement wasn't met, not this one. You can completely disregard that one. And then lastly, there's else. So else is optional. It's only going to execute if all the other conditions are false. It's directly followed by a colon, and there's no condition statement because it's just if everything else failed. And there can also only be one else statement following the if statement because there wouldn't be a reason to have two else statements. So for loops. So many objects in Python are iterable, meaning that you can iterate through them or repeat through them, like in a cycle. Kind of like in Excel, if you have a function and then you want to drop down all the rows, and you double click the side, it'll just keep going until it meets the very end. So we can do the same thing in Python. It's going to iterate through through a sequence of you can iterate through a sequence of characters in a string or a sequence of items in a list. And we use the for keyword to iterate through them. Kind of like with indexing. So with indexing, it would pull the item. It wouldn't pull, if you had a string in a list, it wouldn't index the individual characters in that string, it would index that item as a whole. And you can also do this for dictionaries as well, but it's going to iterate through the keywords. And then we have this structure of the for loop. And it's pretty similar to the if statement. We have the for keyword, we have the condition, and then we have the action followed by the colon, new line, and then the space. And then we also have a temporary variable name here, and I'll show you an example later. So it's just really a placeholder so we can reference the items, like the individual characters in the string or the items in the list, keywords in the dictionary. And then one other thing, so integers are not iterable. So if we had a variable like x is equal to 5, it's not going to iterate through that 5 times. But there's a little trick that we can do just by using the range function. So the range function is going to create, a temporary list of numbers up to whatever range you specify. And it's similar to slicing because the parameters are similar to slicing. So the first parameter is start, stop, and then step. Only difference here is that if we only have one parameter in, it's going to default to stop, as opposed to slicing default to start. And then, so the stop also indicates what it's going up to, but what it's not including. So in the example over here, I have the range equal to 5, and for the numbers in the range, print 5. You see there's 5, it prints out 5 times, but it's not going up to, it's not going 1, 2, 3, 4, 5. It's starting at 0 and then going up to 4. And then I have some exercises for you guys. So the first one is create a variable containing your name and print it spelled backwards. So that's from material covered in the first 2 lectures. Print a list from 1 to 6, but exclude 3 and 6. And then you might need the mod operator from the earlier lectures. And then these 2 are going to be the for loop questions. So in a range from 1 to 50, if the number is even, print even, and then if the number is odd, print odd. And then the last one is going to be a little tricky. So in a range from 1 to 100, if the number is divisible by 3, print fizz. If the number is divisible by 5, print buzz. And if it's divisible by both 3 and 5, print fizz buzz. Else, print the number. So I'll give you guys like, say 10 minutes to try and get those, and then I'll show you how I do them. Okay, so for the first one, printing the name backwards, I have the x variable. And the start is -1. we skip the stop, and then the step is -1, so that it goes backwards. If we leave that blank, it's just gonna go from left to right. Next one, so we have the X variable with our list inside. I just put it reads a lot like English. So for the number in X, and then colon plus the space, then if the number mod 3, which mod is, it will return the remainder, is equal to 0, print, if it's not equal to 0, print num. We have that there. Oh yeah, right here. Four. Okay, and then this one, so very similar to the previous one, for num, and we use the range function. We have to specify that it starts at 1, otherwise it'll start at 0. And then also specify that it ends at 51 because it's up to but not including. If the number mod 2 is equal to 0, print even, else print odd. And lastly, so we start off the same as the other one. So for num in range 1 to 101, and we check for 15 first, because otherwise one of these will trigger it, and it'll never be triggered if we move this one to the last place. So if num mod 3 is equal to 0, and if num mod 5 is equal to 0, print this buzz. And then elif, and we use elif because we only want to check this if this one fails. Elif num mod 3 is equal to 0, print fizz. The same, but we just change it to 5, and then else just print the temporary variable num.